Hi there, it's Z again. And if you just come from part one, welcome back to part two. And in this section, I'll be going over how I built and deployed the web app that I showed you in the demo. Word of warning though, this will not be a step-by-step code walkthrough. I will, however, provide links to the source code that I use. But you can think of this more as a very high-level overview of the model architecture and deployment workflow that I used and my insights that I gained along the way as a novice doing all of this. So this is a high-level workflow showing you how I went from gathering the data all the way to deploying it online. And I use the word sort of deploying it, and you'll see why later. And I'm going to walk you through the steps and the tools that I use. So the very first step was I used something called PassHub for the web scraping in order to generate the training data. Now, I could have gone for a fully Python-only solution, but ended up going towards a tool called PassHub, partly for the simplicity that it offered. So PassHub is a web scraping service that is uh, zero coding. And what it does is you find a page that you want to scrape your data from, and you click on the cells that you want. And what it does is it figures out which are the fields that you want to extract. So if you just click on one, it in a way it infers the other fields because they are the same sort of tags in the website. And it does things like you can even go to individual sub pages where you can tell the tool to click into the URL. And I've done that here, where in this sub page, I built a sub template that tells it to extract the synopsis and the image, and it grabs all that data and dumps it into a CSV that you can extract later on. The only catch is that you have to pay for a premium account if you want to download the images directly. So I ended up downloading URLs to the images and using um, Python to download the images from the URLs. It's still better than having to do this straight through Python itself. So that's the step for gathering the data. Now, the next step is pre-processing and building the model using something called TensorFlow. So I didn't build the code from scratch, and I borrowed it from two examples that I found online. So I'll start first with the text model. The text model was based on a Python script that was part of a Udacity course on Introduction to TensorFlow for Deep Learning. It's a fairly simple model, and you'll see that it's only got a minimal amount of layers, and it uses word embeddings to map the words into a higher dimension and passes it into a long short-term memory layer. And what this is, it's a type of recurrent neural network that is very good for remembering sequences. And the image model I got from this Medium article, and it is a more complicated model where if I just show you what that looks like in terms of the setup, you can see it's got a great many more number of layers for both, and it's got two models, not just one. And conceptually, how it works is you have two models. One is called a generator that creates fake images, and another model called a discriminator that tries to differentiate between fake and real images from the training set. And the whole idea is you wrap the two models into a combined model and you allow them to duke it out where the generator has to progressively get better at tricking the discriminator, and the discriminator tries to outdo the generator by being able to pick out which are fake and which are genuine images. So it's a slightly more complex model. Now, I won't go into too much detail about how the code works. I do recommend that if you are new to deep learning, that you try out this course itself. It was really good in terms of pitching it at the right level for people who are just starting out in this, and reading the Medium article yourself. So instead, I'll talk about the process of training the models next, where for the uh, text model, I pre-process and train the model on my local laptop. So it's not a very complex model in that it doesn't have that many different variables. And you can see that for the title generation, it only takes about 12 seconds um, per epoch. And an epoch is basically where you run through all the training examples. Uh, and for the synopsis, because it's got more words, took a bit longer. So it takes about uh, a bit less, 3 to 4 minutes uh, per iteration, per epoch. It's not so bad, but when I got to the uh, model for the image generation, it was a lot huger. And the reason for that is this is the image generation model, and you can see it's got 3 million parameters, and it was on my CPU. It was easily doing, I think, like 5 to 10 minutes per iteration. And unlike the word uh, text generation model, you have to run quite a number of iterations, quite a number of epochs to get anything meaningful from the image models. So it wasn't going to be sustainable. So instead, I used a service called Spell, and Spell is a uh, online cloud-based machine learning ops site that allows you to borrow computing power. And in this case, I mean GPUs. So it's these graphics processing units that are a lot better at um, running the training for complex neural networks. So the way it works with Spell is you run a command from your local laptop that specifies the machine that you want. And here I used a NVIDIA Tesla K80. You specify the uh, additional libraries that you want in that environment, and any source data that you want to upload, and you can run a script. So after you run the script, you can find your output in a run file, where for the particular run that I did, I generated a H5 file, which is a safe model file, and also some images. If you prefer not to use individual Python scripts, it also has a feature where you can set up a notebook environment instead to get the information, to upload the data, and also to run it using a Jupyter notebook, which is what I eventually did, just for the sake of simplicity. So let me just see if it's set up. No, it's not. Still thinking. Yeah, but here's an example where I ran 10,000 iterations using this particular setup, and it just made my life so much easier. Okay, so it's here. So basically, this will now work like any old regular notebook. And what I did here was I just extracted only the pieces of code that relate to the image model, and I dumped it all in here and grabbed it. So it produces all the different H5 files, and I have one for 10,000 epochs versus 1,000 epochs, and all the images that it produces. I'm just going to stop this because it costs money to run the machines. I'll move on to the next step. So after training both the text model and the image model, the next step is around deploying it. So what I did is I used Flask, which is a library in Python that allows you to build very simple web apps. And I used the train models and wrote a function to call upon the train models to produce a number of variables. So that's this particular function over here, where it grabs information from the title model that I use to generate title text and the synopsis model that I use to generate the synopsis model, and also generates a image from the generator part of the GAN and passes it all into a HTML file. So instead of running it through the Jupyter notebook, I wrote I cut and pasted it into a standalone Python script. I should actually open this in a IDE, and that's fine, and ran it. So once you run it, basically you get a page where currently it's sitting only on my local PC, but every time you reload the page, it will take a little bit of time because what it's doing is it's trying to um, call the various TensorFlow models to generate an image and the text. So it tends to be a little bit slow because of that, but we'll give it a couple of seconds to think. So by doing that, it generates a new random text and random image. The image doesn't look so good, and I'll talk a bit around why in the next video where I talk about some reflections on going through this process. So we're almost there, but not quite. So the trick now is moving from a locally run version to one that is sitting on the internet. And the way I did that is I used a service from Python Anywhere. Python Anywhere is a web service that allows you to run Python script, but also to host web apps online. Now, the only catch that I experience is I put the entire script onto Python Anywhere, but I realized that Python Anywhere doesn't allow you to run TensorFlow from the script itself. It's something to do with the way they set up the threads, and it just falls over. And in any event, you saw for yourself that it takes forever for the page to load up. So I ended up with a cop-out solution where, in a truly meta turn of events, I faked the fake anime generator. So if you look at um, the site, the code actually, I uploaded a bunch of extracted images and extracted outputs from the models, about 100 of these, and the Flask site actually doesn't generate them on the fly. It just selects out of the 100 samples that I've created, it makes a random selection and displays it. So you could argue that this is a bit of a cheat because this isn't actually a website then, but still it runs, and I guess nobody's really relying on this for any critical operations. So I suppose doing it this way still gets the job done. So it looks like this, where you can now load up the site, and it's still output from the TensorFlow models. The only thing is it's not dynamic output. Right. So on to part three.